All right, here we have our sigma goes to infinity, n equals 0, ar to the nth. This is our geometric series. Now let's write out the nth partial sum of the geometric series. S sub n would equal to, let's plug in 0. Anything raised to the power of 0 is just 1. A multiplied by 1 is a, plus, then let's take 1, and this would be ar to the power of 1 plus ar squared plus ar cubed plus dot 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 plus term before the last one and the last term, which would be just a sub n. Now let's enumerate each term. This would be a sub 1, this would be a sub 2, a sub 3, a sub 4, and so on. Now let's note here that our power is always less by 1 than our index in each case. Therefore, we can conclude that the last term would be ar raised to the power of n minus 1. And the term before it would be a sub n minus 1, ar to the nth minus 2. So once we know this, let's multiply this formula by r, since our multiplication by r doesn't change really anything, because once we multiply, we can divide it by r, and that's going to be the same thing. So let's multiply the first term, which would be just ar, and then plus ar squared, this one, and then plus ar cubed, plus ar to the fourth, plus dot dot dot, plus term before the last one and the last term, which would be just a sub n. Now let's enumerate each term again. A sub 1, a sub 2, a sub 3, and a sub 4. Now in this case, as you can see, our index and our power are the same. So we can conclude that the last term would be just simply ar raised to the power of n. And the term before it, which was a sub n minus 1, would be simply ar to the nth minus 1, right? So now what if I'm going to cancel them all? So I'm going to cancel ar and ar squared, and so on. Just cancel with me. What I have here, ar to the fourth, but it would be there. I just didn't write it out. So just assume that it was there. So on this would cancel out with this one as well, and cancel out this. And now, as you can see, we're left with this part and this part. There's no mathematical concept where you can, cancel things like this, but what I just wanted to show is that the real difference between s sub n and s sub n multiplied by r is that s sub n multiplied by r just doesn't have this a, and s sub n just doesn't have this ar to the nth. So then I would sit there and say that then s sub n plus ar to the nth is the same thing as s sub n multiplied by r plus a. Because again, take a look that now I'm saying that s sub n plus ar to the nth, and now we have this a here, right? Because s sub n has this a, and s sub n multiplied by r is just plus a, and since it already has this ar to the nth, we can just conclude that they're the same, and this would be absolutely correct. So now let's sort it out a little bit. So let's subtract from both parts s sub n multiplied by r, and let's subtract from both sides ar to the nth. We would get s sub n minus s sub n multiplied by r equals a minus ar to the nth. Let's factor out s sub n from this part, which would be 1 minus r, and you can spoil it out, and you're going to get the same thing, equals to, let's factor out a from here, and we're going to get a minus r to the nth. And what about if we're going to divide both parts of this equation by 1 minus r? What are we going to get? We're going to get s sub n equals to a, by the way, here's the bracket, 1 minus r to the nth over 1 minus r. And here it is, the nth partial sum of the geometric series.